Piecewise functions are literally hybrid functions. I'll draw one for you so you can kind of see what they look like. Let's say you had a function like this. Okay. And on this side, it's a line like that. And there's an open point right there. It passes through -1, -2. So you got that line there. This is -1 and -2. And then right here, we have what looks like a parabola. It passes through 0, 0, 1, 1, 2, 4. So that looks like a parabola. And let's say it's closed on both ends, like that. And then maybe there's another function, like a third piece, that starts here and goes down. We'll make it a straight line just for our first example. We don't want it to be too complicated. So what is this thing? Well, first of all, is it a function? That's an important question. Maybe it's not even a function. How do you test that? Vertical line test. Okay, so what you do is you draw a vertical line, right, and you just move it along. So you just slide it along. If it ever contacts the graph more than once, then it's not a function. Okay, so is it contacting the graph more than once here? Now it's touching once, right, where the vertical line meets the blue line, or the tilted line. Excuse me. If I get right in here, this is right at x equals 0. There's an open point and a closed point, right? The open points don't even count, so it's only touching once technically right there. So it still seems to be a function. You can keep on moving. Right now it's only touching this parabola piece. When you get to x equals 2, it looks like you got double contact there, but you don't. Again, the y point doesn't count, just that top point up there at 2, 4 counts. And then after that, you've got contact with this tilted line once at most. So it is a function. You guys agree? Yeah. Okay, but what's the function rule? Well, the function rule is going to be a mess. What's the function rule? Let's write that down. First of all, it's going to be f of x equals, and it is not going to be one expression. It can't possibly be just one expression. It's going to be made of multiple expressions. All right, so let's just go back and look at this thing piece by piece. The first piece is clearly the line y equals, what's the slope of that thing? What do you guys think the slope is? The slope is 1. It goes up 1, right 1. Okay. What's the y-intercept? -1. Okay, passes through the y-axis at -1. Okay, so that's the equation of that line. So I got to put that over there on my f of x. Let's see here. I've already written the y equals. See? This means y equals, right? So I don't need to write y equals. I just need to write x minus 1 up here. X minus 1. That's part of the function rule. And then we got that parabola. That's clearly x squared. I guess it could be x to the 4th, but then it wouldn't contain the point 2,4. It contained the point 216, right? So I'm going to say that that's y equals x squared. Seems like it is. So I've already written y equals, right? F of x equals. So I'm just going to write x squared. There it is, y equals x squared. Y equals x squared. And the third line, can you tell what the slope is? So basically it goes from the point 2, 2 to the point 4, 0. So it dropped by 2 and went over by 2. Its slope is -1. What's the y-intercept? You have to kind of extrapolate backwards, but if you keep this thing going, 4. Okay? My graph's not perfect, but it's 4. So plus 4. There we go. So negative x plus 4 is the third function rule. So what I've done is I've described the various pieces in one function notation. Okay, the only problem is if you gave this function notation to a person and asked them to graph it, this one, right, they would not draw that. They would draw basically this. They would draw too much because you never told them which parts to draw. Okay, so now what we need to do is write down the domains of each of the three pieces. Okay? For example, that first piece is not an entire line, right? It's actually just array. And which side of the x-axis is it on? Or the y-axis, I mean? Just the negative side, right? So this is only reserved for x is less than 0. For x is greater than 0, we have some other stuff going on. But for x is less than 0 on that interval, we're dealing with this piece. Piece number 1. All right, so we need to write that in right here, see? We need to write that this is meant for x is less than 0. And that piece of a parabola, that is not an entire parabola. That is just the part between x equals 0 and x equals 2, you see? So we're going to write that. We're going to write between 0 and 2. And it is inclusive. Notice the parabola piece has double bubble, right? Two nice black points on the ends. So we're going to include those. Those are inclusive inequalities. As for that last piece, that line, that thing doesn't even start until you get to x equals 2. And then it's really drawn thereafter. So this is the piece for x's that are greater than 2. Okay, so I had said that this kind of thing could actually show up in real life. So what was I talking about there? Well, let's say there's a company, right, and they want to rent out cars. So you really need a rental car. So you go down to this store, and this is a really crazy place. These people are a bunch of cracks. Maybe it's called Duck Rent-A-Car. Okay? So you go to Duck Rent-A-Car, and you're like, I want to rent a car. And they're like, okay, it's $25 a day. It's $2 a mile, which is really expensive. Unless you have the air conditioner on. If you have the air conditioner on, the first mile is $2, and the rest of the miles are $3 each. If you drive it past 40 miles, there's a wear and tear fee of $12. If you want the insurance, that's $15. If you're already insured and you want to just add supplemental insurance, then it's only $12. This is like a nightmare, right? It's like, can you figure out what you're going to pay, right? If you were to graph this nonsense, well, you might get something like that. A broken, discombobulated Frankenstein graph, where f of x stands for Frankenstein of x. Frankenstein was stitched together from various body parts. Okay? This graph is stitched together from various shapes. And they don't have to be lines and parabolas. We could put any graphs together in this way. Okay, so it does happen in real life. You should see cell phone bills from the early 2000s. I got my first cell phone bill, and it was $420. So I was like, okay, I'm a moron, right? How did I make that happen? Well, so I called up the company. That was Pacific Bell was the carrier at the time, and they had just started a cell phone branch called Singular. Probably never even heard of it. Okay, right around the time when you were born, probably. Singular was made, and I had a Nokia phone, and it was a Singular plan. And I called them, and I was like, okay, so I owe you $422.76. So what am I paying for? Oh, well, there's these fees. I'm like, yeah, I know. Thanks for patronizing me. Can you please tell me what they are? Well, yeah, there's this fee and that fee, and I have no idea what they're talking about, right? If you look through the actual statement, it's like, what am I paying for? It's just fee this, fee that, tax this, tax that. Since then, things have gotten a lot better, right? I get a message on my phone saying you're running out of minutes or you've used too much data, whatever. All that's more regulated now, but you should have seen it back then. Piecewise functions for everything. Okay? You guys understand what I'm saying? Why would nature not be like this? I mean, why does everything have to be nice and smooth, you know? It doesn't. So this is how we glue graphs together, and this is how we use the notation. So I want to demystify this, because when you see this in the textbook, your first thought is going to be like, what is that? Maybe. First of all, I want you to read it like this. When you see this, don't say x minus 1. Say y equals x minus 1. Okay, so let's try it. Y equals x minus 1. Y equals x squared. Y equals negative x plus 4. That way you'll realize, oh, a line, a parabola, a line. See what I'm saying?
If you were to graph this in your calculator,
You can graph on
would you do
calculator.
3 different functions, or would you put them all under one function?
I think some of the newer TIs, you can do them all under one. But I'm going to demonstrate how to graph this one with an older operating system. I think what you have there, Jack, is the newest operating system. So it's a little more advanced than what most people are going to have. So let me just show you how we graph this thing. So you turn it on, right? And you're going to enter in the first rule, which is x minus 1. You want it in parentheses, though. So x minus 1. Okay? And then you want to tell the calculator that you only want that for x is less than 0. So what you do is you put a slash, which is your division button. So divide, and then you do parentheses, and you want to type x is less than 0. So how do you type that? You do x. You'll find the less than button under test, which is second math. See it? Second math. It's called test. If you press second math, you'll see it's right there. There's an equals, there's a not equals, there's a greater than, a less than, and so forth. We want less than 0, close parentheses. Okay, now if you graph that thing, watch. It graphs the line x minus 1, but it stops when it gets to 0. Okay, so I'll put that function rule back up. I type x minus 1 in parentheses, and then division, and then in parentheses, x is less than 0. It's also online if you need to research how to do this. But I'm recording right now, so I'll post this on YouTube if you need to review it. Okay, now I need the second rule, which is x squared. Now this is what we call an extended inequality, so it's going to be a little bit harder to type. It's from 0 is less than or equal to x is less than or equal to 2. That's harder to type. But first we need to put x squared in parentheses. Okay? Then we're going to do the domain, so divide. And there are two rules here. X must be greater than or equal to 0, and also x must be less than or equal to 2. So you're going to have to type the first rule in its own parentheses. That is, x is greater than or equal to 0. You also want x to be less than or equal to 2. So after you close your parentheses, you want to open up a new one and type x is less than or equal to 2. Like that. I'm going to graph it, and then I'll bring the screen back up again so you can see it again. Look, it's going to graph the line and a piece of parabola. Nice. That's exactly what we had. Okay, next is our third function rule. Go down to y3. This time we're entering the function negative x plus 4, close parentheses. The domain is x is greater than 2. So divide, and then in parentheses, x is greater than 2. There's your last piece. The only thing it won't do for you is put on the open point, closed point. Yeah, anyway, you're supposed to put, that was supposed to be at the origin. It won't do these for you. It can't do open points.